All right, so let's go. This chapter is a bit short. So,
Awesome.
the chapter is what is called an arrow. And the motivation of this chapter is when you have large amount of, files, not file, records in some ways. Your file maybe, will be large, such as CSV format, and the record in CSV format is not good in terms of processing that file. It's not efficient. So a better approach is needed to, process a file or a record with large amount of, information. So that's what the, Apache Arrow provides support for this kind of pack file, which is used in multiple languages, not only for R, but also Python. They have Arrow in Python, Arrow in Java, or something like that. In R, that is called Arrow package that is used to, provide this kind of large processing of memory, data to analyze larger than memory data set using familiar devices. So it's using also deployer sectors, which we have already saw in the previous one, and it's extremely fast. So sometimes he made mention, when are you going to use either Arrow or dbplyr? So we also discussed, remember, dbplyr last session, of processing the data from database. So he said both of these two can be used, but if your data is already in Arrow format, just use Arrow. If it is in database, then you can use dbplyr. That's the best thing to do. Now here, this is really difficult for me, like downloading the data 9 gig. So I don't know, anybody tries to run this chapter? Anyone?
Yeah, I don't think so.
So what happened is this data is 9 gig. So I tried downloading, but actually it's been difficult for me to get this. So by the way, it just the main aim is for us to see, like, how can we work with large amount of data, right? So here we download the data. We can see it's large enough that we probably don't want to load to the whole into memory, right? So it is 9 gig data. So loading this data into memory, it will be really difficult for us, because maintaining this, because one of the rule of thumb they made mention is this. A good rule of thumb is that you really usually don't want to usually at least twice as much memory at the size of the data. So if your data computer is 16 gig RAM, so you can see you have 9 gig RAM, which is not the rule of thumb. So it's gonna be difficult, right? So I have this. So right. I don't know if let me try and see if actually I didn't manage to download this large data. So it's today the session, maybe I
Yeah,
think.
it's okay. It's okay because it's very big.
Yeah.
Don't use it
So,
even. So
yeah, so
yes.
maybe I don't know if it is better to look at the book, because we can see the output or whatever. Okay, so let me just continue. So here they basically download the data, and now here I think what is best is just maybe to look at the book. So
Yeah.
let me share this. Let me share. Hey Abdul, how are you?
Yeah, I'm fine, guys. I finished praying not long ago. I joined you.
Yeah. How is have you defended your PhD?
No, not yet. Still on the process.
They approved my my external examiners, so hopefully my supervisor saying if I've not done it now, maybe it should be in September, but I hope to do it in this month.
Yeah, I'm hoping as well in September,
Okay, so me
Yeah.
too. All the best.
point.
Ahmad, you heard us talking about defense. We are all students still. Yeah.
Yes,
Okay.
we're all a life student. We still student, even if we graduate.
You maybe already finished. We are still a student, me and Ab. Okay. Right. So here we can see the downloaded data, which is this. And now they open the data like this. And now we can see this is the data, right? So this is the data. I can go here. So after glimpse, doing the glimpse, and we can basically do anything we want with our data, more or less like the way we do with, deployer, like count, arrange, and collect. Allows you this one. This is it. So you can see here we do glimpse, right? And we see the output, file of this, and we can do the thing that we normally do in the, deployer. So we can start with this data using collect, pose the arrow to perform computation and return some data. So at the end, we pause it to return the data. So this is basically just showing us how we can, use data in that form or the thing also you can see here is that we use a function called open data set. So open data set is from arrow, you can see it. You can use it to download very large data. You can see you provide the source and you provide the format. So it's not read CSV that we did right here. So yeah, so it's not read. And here you can also hear that is also multi-download that we just download the data, but opening the data here, we use this function, which is from arrow. So yeah. Anyone wants to add anything before we go to this format?
No, we are good.
Okay, so just like CSV, the format of this is also rectangular. But instead of text format that you use in any format, it is custom binary format. So it means that packet files are usually smaller than file CSV, so they are rectangular format, but they are usually smaller than the original CSV file. Because this packet does some kind of compression. So this is one thing. Number two, packet file are column oriented. This means that they are organized column by column, much like r4ds. This is typically lead beta performance. So I don't know why this is so. So what they are saying is the files in these, they are organized by column, right? I think this is what they mean.
Yeah, no, I know what, yeah, I get it. Because let's say normal CSV files is or normal databases
Yes.
are storing data row by row,
Yes.
like inserting row by row. But
Uh-huh.
in this kind of formatting, which is the kind of format when you deal with big data, you could see it also in data warehouses, how we could use this kind of format. So instead of inserting data or storing data row by row, we are inserting column by column. Is like the whole column inserted like a one insert. This is
the whole column is like one record.
Yeah, this is the one unit. And by doing this, because we are doing basically analytics, we don't need like really specific rows. We want an aggregation overall.
Yes.
This really add some kind of quick performance to the
I see.
because we are using like aggregated function like mean, median, or anything like that.
Okay.
This what they explained here.
I see. So what you are saying is, if we have data, column oriented data is much faster in terms of processing. Is that correct?
In terms of analytics workload.
Yes. Okay.
Yes.
Okay. Oh, I didn't know this. Now I get the point. Okay. And so you can see 2 points. Number one is the files, unlike CSV, are compressed. Number two, they are column by column. Number three, packed file, unlike CSV that we have only one file, they are chunk. meaning given a very large file, 9 gig, so it can chunk them into separate file, bit small by smaller size, so that it can process small files faster and move to the next one. So this makes it, easier to process big data. So this 3 point. That means, that being said, we can see that we take a very large file in part and chunk it. So it means we are going to do what is called partitioning. So this is one of the things that involve impact. So it involves partitioning your file into different chunks. So this is it. So now how do you partition? So this is what they're saying: as data set get larger, so all the data in a single file get increasingly painful, and it's often useful to split the data set across many files. This is also talking about this. When this structure is done, then the study can lead to significant improvement in performance, because many analysis will only require a subset of the files, right? So this means that, for example, if we trying to perform some analysis of some variable or some column, we don't need the whole data. So for example, if we have a single data and we want to process maybe one entry, if it is in row by row, we need the whole data, but this one with column, so chunking the data, you can take some smaller subset and you can do any other thing. So so you can see as a rough guide, Arrow suggests that you avoid files smaller than 220 MB and larger 2 gig. So what they are saying is the way we do partitioning can be greater than 220 MB, but less not larger than 2 gig. So for example, the 3 gig data we are starting to work with, so we can maybe chunk into 9, like 1 gig, 1 gig, 1 gig, something like that. So that works. So that being said, now let's see whether we can change this CSV data from CSV and chunk it to partition it. So that's what they might want to do. So we can see this is the data, right? CRD data, and we have that right data set. This is the data, and format is this pack. How do we pronounce this? Can somebody help me? Packet or what?
Parquet.
Packet.
Parquet.
Okay. So you can see here we have the original data, but we want to save it in Parquet format, meaning we want to partition, because when we want to save it in Parquet format, automatically we must chunk it, partition it. So here you can see that they are doing this. So going through this, tables, files, whatsoever, we can see that, and we are saying how much we're gonna divide. So here you can see we are just trying to look up let me see, right data set for this. Okay, so here we just save it at this packet format, and now we are trying to read it and see how many size do we have for each file. So this is what we have. So you can see here we have our single 9 gig has been written into 18 packet files. This is the size, and you can see the format: part 0, 5, part Y, something like this, but this, and they have checkout here and whatsoever. So this is basically just telling us, showing us how we divide our data set into this packet format. Okay. Okay. Anyone wants to add something? So the main idea here is that when we have large file, the takeaway is CSV, it's just to save it as this format. Don't bother about this group by, it's just some operation, but the main idea is we have CSV, and now here we, this is the path we want to save it. You can see that, right data set, this is the function, and you provide the path, and now provide the format, this save it, and automatically it, you can see we didn't specify how many partition do we want. It is this file, the right data set automatically determine how many number of times it will divide it. So here it divide into 18, because you can see here we didn't say divide it into 18, it automatically divide that, which I think is best way that they can be able to divide this 9 gig of data. Right? Anyone wants to add something?
No, we are good.
Okay, so we can see now our packet file is in this location. Now, how can we now work with these files? Because they are now chunk, right? They are divided. We can use basically dplyr. The same, the back end of the dplyr can work with this packet. So, but because we are using the packet data set in this, we are not using read CSV or anything. So we have the function called open dataset. We have a function called write dataset. So all these functions, they are the one that we can use in packet. So write dataset, open dataset, they are the one that work with the open data with the packet format. So let's look at that. We write settle, we read the dataset, then we can use basically our normal operation we do with dplyr, which we can see here, query, you can see this is it, and we can do collect. So for example, here you can see finally we didn't call collect, right? It just shows us the file data in packet format. But if you want to return the result, we need to call this collect, right? So you can see we have our collect. We do basically normal our analysis with the data set, right? So we can see now the main takeaway. What we learn is we have open data set in packet, we have write data set in if your data is already in packet format, just use open data set to read it, and now use normal dplyr and call collect at the end. If your data is not in packet, it's in CSV, what you need to do is save that data into packet format and now read, open it, write it, save it, and now open it again, and now work normally with that. Right. Anyone wants to add something?
Yeah, I think to use the open dataset, I think you should like provide the path, the directory that contains the partitions of the file. It's like it's scroll down. It's in down. Yeah, here. Yeah. Let's go up a little bit. Before that.
Oh.
Yeah, so we have created files. We need to again open the set, but give it a directory here. You have to provide a directory that contains all the files that all the files.
Yes.
That's how you read it.
Okay.
Yes. I think it's recursive, like it's going through it as a loop.
Maybe, yes, exactly. So we can see here that we define this, the path where to save it, and now here we save it and pack format. So now this open data set, we just specify the path where we save it. So it's in some way it's recursive, I believe, like because it partitioned them, so it will read them, recursively and whatsoever, and now store it in settle packet data. So here we can just work with it. But do you think instead, I think this will also work. Can we say that open dataset packet here just directly, and now just like read CSV, and you put this one? Do you understand what I mean?
Yeah, I think it will work. Just because you are sending it to a variable. So
exactly. All right. So here they basically, check out the performance to see what works best. So let's look at performance of switching from CSV to pack. First time, how long it calculate the number of books checked out in this when the data is stored in a single CSV. So you can see how much the time, you can see how much the time in packing, you can see how much the time. So you can see definitely it is faster to work with packet format. So look at it, 100% speed of performance. So this is interesting. So you can also use dbplyr with arrow. So there's one last advantage of packet and arrow. It is very easy to turn an arrow data set into a DocDB. So we already saw in previous session, we already saw how we can basically use DocDB. So here they are saying you can change your, arrow data into DocDB. So here we can see we have data, I think. So they just to DocDB. So this is just a function, DocDB that can use, but I don't know why do we need to change the data into DocDB, because we can work seamlessly with the arrow, or maybe in the data. I don't know. Do you think anything?
It,
Ahmad?
like I think because you want to take like convert it into the database, like store it someplace, not just
Okay.
use it.
Okay.
And
Okay.
when you use it afterward, you can transfer it back to the Parquet and now work in it.
Okay. Right. Okay. So that's all about the chapter. As I said, the chapter is so short, and yeah, we have next chapter is hierarchical data, which is Ahmad, I guess, right?
I don't remember it. It's in
Okay, this is very interesting chapter. It's always difficult for me. Hierarchical data, where you deal with JSON file, it's
oh,
very,
I think this will be an interesting one.
yeah, it will be interesting one. JSON like is super next state and whatsoever. So how you can deal, and all those stuff. So this is interesting, the chapter thing. So let me look at our uh for what it? No, we are good.
We are 8.
Yeah,
Oh yeah,
Ahmad.
yeah, it's me. Okay.
Okay.
It
So
will be,
Abdul sign off for web scraping and functions, right?
yeah.
Okay.
On it is interesting also.
Yeah, all these ones are also interesting. These ones. No, we are almost done, I think. Right?
Yeah.
All right. Thank you
We'll
very
try
much.
to finish it. I think we'll in the
Yeah.
next month.
Yeah. Maybe if we come to this, maybe we can combine some session, I think, like Quattro and whatsoever, we can combine them into even one or something like. I don't know if we feel like.
Sure. No, why not? So Abdus is out.
Yeah, it's out here.
Okay, let's wrap it up here. And thanks for the presentation. It was a good short one.
Okay.